Welcome to the Majestic tutorial. Of course, you are watching the Majestic tutorial, where top teachers deliver simplified lessons across major art and science subjects, a true hub of expert teachers and impactful learning. As you enjoy the class, don't forget to subscribe and share, please, with others. I cannot do without you. So I'll be handling JUPEB Practical Chemistry. I'll give you the specimen, which you can see here, the list of the specimen, and then I'll handle the likely questions. Over here we have acetic acid, which is meant to contain 1.5 gram per 250 ml of solution, and then B is a solution of sodium hydroxide, which is supposed to contain 4 grams in 1000 ml, that's a 1000 cm cube. Then hydrated copper 2 sulfate 6, which can be any, the N, it can be 5, is not a must to make it pentahydrate, but just know that you are going to provide something that is blue. It's going to be blue salt. Then zinc dust is Y. Then Z is ferrous sulfate. Ferrous sulfate is iron 2 tetraoxosulfate 6, and they said it should be pentahydrate. So that the reason for these hydrates they are giving it is that to make sure that the color is maintained. Okay, so then phenolphthalein is indicator, of course, because we are looking at titration between a weak acid, which is acetic acid, ethanoic acid, and a strong base, and the suitable indicator in this case is phenolphthalein due to the pH transition range. Then normal thing we need for titration and salt analysis, burette, all those ones, look at these ones. So I will solve them, and then we will look at the likely questions. The likely questions, let me display them now. I'm going to display the likely questions now. Okay. I think I have to lift this one. Yeah. That's, here we go. These are the likely questions. To zoom in. So, likely question 1, of course. I'll handle this one. That's my first shot. Then you join my live stream on the last day before the exam, where I'll give you the other questions and attend to your own private questions. All right. So looking at this, the way this question was constructed, we are targeting that this should be 90% possible question that will appear. All right. So we are looking at the strength given 1.5 gram in 250 cm cube is the same thing as ml. So all this information are what we need. We need to know what they say A is, and the A is just a monocarboxylic acid. That means it was hidden, it was not mentioned. And then B is 0.1 mole sodium hydroxide. Remember, they can give it to you in mass. Okay, after giving us the whole equation, they say from the results and the information, you are to tabulate your burette readings and determine the average volume of A used. So to solve this, I need to clear this question and then start writing. But the effective way is that we got to make here. It will appear now here. Okay, see the questions, then I will solve them right here. Okay, remember to ask your questions. So as you are seeing the questions being displayed, the solution, here we go. We will need to make a table, but first of all, the end point from this titration is 25.00 cm cube. That's the end point. If you use, so to start with, your end point, according to these equations that were mentioned over here, the particular thing they said we should provide the strength between A and B, the end point, if you use 25 cm cube of, if 25 cm cube of B is used, our endpoint is also 25.00 cm cube. So because if you look at the information provided over here, if you carefully see the information here, they are of the same strength, because this is 1.5 gram in 250. How many will be in? Remember, this is acetic acid, which is ethanoic acid, but I decided to hide it here, okay, calling it monocarboxylic acid. So but if you, since their strengths are equal, the volume that they will consume will be equal, because the mole ratio is 1:1. 1 mole of the acid will be neutralized by 1 mole of the base to provide 1 mole of the sodium alkanoate, and then plus 1 mole of water. So 1:1:1. So if 1:1 and the strengths are equal, me looking at B is already clear that B is 0.1, and I'm telling you that A is also 0.1. So if you use 25 cm cube of B, your endpoint will be 25. If 20.0 cm cube of, but they say we should provide 25, I guess, in that instruction. 20.0 cm cube of B is used, our endpoint will also be 20.0 cm cube. Remember, you are not restricted to get 25.0 cm cube, which means you can use 24.9, 25.10 is accepted. This is accepted range. Then remember to keep the rules, put it in 2 decimal places. So I'm now going to proceed to making of the table that we'll be using in this titration, of course. So in that table, maybe I will make it in this space here. Maybe decide to use here. Remember, you are going to specify the volume of indicator, the volume of pipettes used, of course. So maybe our rough is 26.50. Here is 0.00. 26.50. The first one we look at 24.90. 0.00, 24.90. I have a 25.10, 0.00, 25.10. Then we have our 25.00, 25.00, no. 0.00, so that here is 25.00. Alright, follow this rule. We have made our table. Now, because of space, I just used there because I want to use ruler. Let me now come here and continue other calculations. They say tabulate your burette reading and determine the average volume of A used. Tabulating my burette reading, I've done that justice to that, and the next thing is to determine the average volume of A used. I'll now say average volume of A bracket VA is equal to, tell the examiner, from my table all my readings are concordant except the rough, so I can use first, second and third readings. So I have my readings as 25.10, or tell the examiner you are using first plus second plus third, all divided by 3, and my first theta value is 24.90, second is 25.10, third is 25.00, all divided by 3. So if you check all this, we are getting 75.00, all divided by 3, we will get 25.00 cm. So we have gotten the average volume of A used. Now the next question says, they say the equation of the reaction, they gave it to us from your results and information, concentration of A in mole per dm cube. So for us to calculate concentration of, that's 1bi conc of A in mole per dm cube. Remember, this is also called molarity, bracket molarity. You can see this as calculation for molarity. Over here, there are two possible formulas you can apply, but which one will we apply here? We will apply the Carver formula according to my students, CAVA all over CBVB. They call it Carver formula, but there is no universal acceptance to that terminology. Carver because of CA and VA. So CA is concentration of acid in mole per dm cubes. VA is the volume, which is 25 we have gotten. Now we are looking for CA. You are advised to make what we are looking for subject to the formula. From the relation here on the board, CA is equal to CBVBNA all over VA divided by NB, of course. Now another formula that I can use is, I might try using mole per dm cube is equal to gram per dm cube all over gram per mole. But why can't I use this? This formula will not work in this case. Rather, this will work. Why is it that this one cannot work? This one cannot work because we don't know this. We don't know this mole per dm cube. We don't know the gram per dm cube, and we don't also know mole per dm cube. Meaning, we don't know the molar mass because the question said is a monocarboxylic acid. You see where I underlined it. They said that it is a monocarboxylic acid, and with that information is not enough to say that it is you cannot determine the formula. So you cannot the molar mass. You cannot know the molar mass. So we have two unknowns here, which are mole per dm cube is unknown and molar mass is unknown. We can't use this. So if in this case, if this formula doesn't work, the next is this one. Let's assume they mentioned the acid correctly. We will find the molar mass and use the formula that I just cleaned. So we now move on to substitute values our CB has been given in the question. Look at it here. CB, they told us that it is 0.1 mole. That is our CB. Okay, our VB is 25, the volume. So our CA now will be 0.1 times 25, which is the volume of pipette we are going to be using, times 1. Na is 1. Why is Na 1? Come here, my dear. This is A. This is the mole ratio. You see there. So that's the mole ratio of the acid. NB is also 1. That is also 1:1. Therefore, I continue. I'll divide by, what's my VA? That's the volume of acid used, which is what we got here as 25 also, times what? Times 1, because NB, which is highlighted over there, is also 1. When you look at this, they are all equal. You don't need to waste time pressing calculator. Just 25, cancel 25, 1 goes. So we left with 0.1. So since the equation of the reaction shows 1:1 and their strength, the strength of the acid and base are equal, we'll still get the same thing. So Ca is automatically equal to Cb, which is 0.1 mole per dm cube. Remember to put unit after solving. Then what is the next question? The next question says the molar mass of, we have to find the molar mass of this particular A. Now, how do we find the molar mass? We now go back to the information given about A. So BII, A says that it is a monocarboxylic acid which was prepared by dissolving 1.5 grams of the acid in what? In 250 ml or milliliter, that's cm cube. If not in 1000, find out the one in 1000, because one dm cube is equal to 1000 milliliter, and what we have been calculating is gram per dm cube or mole. The formula we've been using here, like this one, is mole per dm cube. Remember in exam it also means mole per 1 liter, or mole, 0.1 mole per 1000 milliliter, whichever unit. I want to clear you here that the dm cube I'm using, 1 dm cube, is the same thing as 1000 milliliter, which is the same thing as 1000 cm cube. So cm cube and milliliter is the same thing but different terminology. Milliliter, cubic centimeter, is the same thing, then which is equal to 1 dm cube, and all these things still means 1 liter. So be careful, no matter the units they are using. Solve well. Now, concentrations are only found in the volume, standard volume of solution, 1000 milliliter, which is the same thing as 1000 cm cube, which is also the same thing as 1 dm cube. So the question have not given us that standard volume. The question just said 250. So we have to ask ourselves to say, if 250 ml were able to contain 1.5 grams of the acid, whatever 1000 ml contains is the molarity. So we call here x. Now cross multiply. We have that 250x is equal to 1000 times 1.5. And 1000 times 1.5, we have 250x is equal to, this is 1500 divided by 250, divide both sides by 250. So we have automatically that x here should be 6 grams per what? dm cube, which is the same thing as 6 grams per liter of solution. Right now, they now told us to find the molar mass. How do you find the molar mass? You go and bring the relation which says that mole per dm cube is equal to gram per dm cube all over molar mass, which is the thing we call gram per mole. To interpret this in words, it means that molarity is equal to mass concentration all over molar mass. My dear, do you know now we have established there is no more 2 unknowns. We only have 1 unknown. What is the unknown? This one. Molarity is what we have found already. in the II, which is, we got it as 0.1, that is Ca. Then mass concentration is automatically this we got here, which is 6 gram per dm cube. So we are only left with this thing that is unknown. We can now make it subject of the formula. So making subject of the formula here, molar mass is automatically equal to mass concentration divided by molarity. Yes, that's concentration in gram per dm cube all over concentration in mole per dm cube. Having this clear, molar mass of A will now be equal to, what's the mass conc? 6 over, what's the molarity? 0.1. So 6 over 0.1 will automatically give us 60. So molar mass of A will be equal to 60 gram per mole. Please put units. This is our final answer. To check the calculator to make sure that 6 divided by 0.1 is 60, we have, okay, so divide by, is that 60 or 6? Question said 6. 6 divided by 0.1 is equal to 60. So I am very correct. So our answer here is 60 gram per mole. Then proceeding to BII, I said molar mass of the molecular formula. Yeah, the molecular formula of A. Yeah, this I'm highlighting. So we can now forge ahead. The question have already told us that look up here, that A is RCOOH. So we can find the molecular formula since it's a monocarboxylic acid, and the molecular formula, the general formula for monocarboxylic acid is RCOOH, which we have found as what? 60, the total thing. But do you remember what R means? R means alkyl, an alkyl group, which is represented by the formula CnH2n plus 1. So we are free to replace this R now with the formula CnH2n plus 1 COOH equal to 60. Okay, bearing that in mind, we can now factorize, or rather do the things we already know. We have seen carbon, we have seen oxygen, we have seen hydrogen, and they gave us the values of these in brackets. And the questions are actually crafted. This question is drafted by me to teach you the basic thing you need. So looking at here, you have the values given. C equal to 12. So I will now replace this. Remember, there is 1 here already. So we will have that. I think I got to go to the next page, or rather take this up. I think it's better I take this up. Yeah, because I was solving at the half page. Okay, we still have a lot of space. Wow, just started in the middle of the page. No problem. So I'm gonna continue here. We look at this. I will replace the values of C for what C is, which is 12. So CnH2n. Remember, you are not going to put 12 here because you don't know the value of this thing. Plus 1 plus 12 plus oxygen is 16. 16 times 2 because oxygen is 2 there. So 16 times 2 plus 1 plus just 1 atom of hydrogen, which will give us, we'll weight everything to 60. Summing all these numbers, 16 times 2 is 32 plus 1, which is 33 plus 13. Am I with somebody here? 13 is 1 plus 2. So looking at all this, we have 2 plus 1 is 3 plus 3 is 6. So 3 plus 1, which is here, is 46. So we are going to get 46 in total, such that CnH2n now plus 46 in total equal to 60, such that CnH2n is equal to 60 minus 46. And then CnH2n, 60 minus 46 will give us guess is 16 or 14 I guess. Yes, it's going to give us just pray I am right. It's going to give us 14, of course. Then we factorize this. There is n. It should now be CH2 all brackets by n, because if you use n to multiply everything in this bracket, you still get the same thing here. Okay, so mathematically we move on. Carbon is still 12. This way we'll now fix it. 12 plus hydrogen is 1. 1 times 2 here is still 2. So instead of CH2 bracket n, we now have 14n equal to 14, such that now n alone will be equal to 1. Isn't that amazing? Yeah. So when we solve like this, we will get that n is equal to 1. You now come back to get the formula. It's obvious that we have said what formula, CnH2n plus 1 COOH. So instead of CnH2n plus 1 COOH, which is the formula, we have found out that n is 1. So C times 1 is still C. H, 2 times 1 is 2 plus 1, which is 3. So CH3COOH, which now comes back to ethanoic acid or acetic acid. That case is settled. Now they say the number of hydrogen ions in 250 cm³ of A. The number of hydrogen ions in 250 cm³ of A, that one is just in case. So we have number 1 BIV, the number of hydrogen ions, in 250 ml of A. First of all, we will say that, remind ourselves of Ca. The molarity of A is 0.1 mole per dm³. Remember, this is a guide, and lest I forget, you are still on with the Majestic tutorials. Please, you are still watching. Yes, of course, Majestic tutorials, and I encourage you to subscribe and share this video. Come back for testimony after your exams. I cannot do without you. Then what we want to clear here is that Ca is 0.1 mole per dm³. What does this mean? This implies that in 1000 cm³ or 1000 ml of what? A, that there is 0.1 moles of A. Yes, then A, having gotten the formula that A is CH3COOH, we dissociate it into CH3COO minus plus H. This implies that 1 mole of the acid will give us 1 mole of hydrogen ion by dissociation. Why? Because our dissociation gave us 1:1. But let's assume it's not this is a monobasic acid. Why is it monobasic? Don't confuse monobasic and monocarboxylic. Monobasic acid is an acid that have only one replaceable hydrogen ion in its molecule. Like HCl is monobasic, HNO3 is also monobasic, but H2SO4 is dibasic. This one will dissolve such that 1 mole of this will give us 2 moles. Okay, but with reference to what they gave us, which is acetic acid, 1 mole of CH3COOH will automatically dissociate to give us CH3COO minus plus H plus. That means 1:1. Therefore, our Ca is also 0.1 mole. But the 0.1, be careful, was contained in what? in 1000, but they asked us how many will be in 250. So if 0.1 is in 1000, 250 will be containing what? 250 will contain 1000x equal to 250 times 1. Remember, it's cross multiply that I'm doing here, such that x is 250 divided by 1000, divide both sides by 1000. So we have now 0 point, and cancel. At the end, we have 1 over 4 left, and 1 over 4 is, I think, should be 0 0.025 or 0 0.0. But to clear doubt, so we have that. Okay, please, is 1 over 4 is 0 0.5, not 0 0.2, not 0 0.025, it's just 0 0.25 moles of the acid is in the volume provided. And from our balanced dissociation of the acid, 1 mole of CHCOOH automatically gave us 1 mole of hydrogen ion, which implies that 0.25 moles of the acid will also give us 0.25 moles. But they asked us the number of hydrogen ions. We bring in now Avogadro's number, and according to Avogadro, 1 mole of any substance, just like a dozen contains 12, 1 mole of any substance will contain 6.02 times 10 to the power 23 formula units or repeating units of that substance. So automatically, we will now have that 1 mole is represented by 0.6, is represented by 6.02 times 10 raised to the power 23 hydrogen ions. 0.25 will also contain X. So you use your calculator here and find out that X is equal to 6.02 times 10 raised to the power 23 times 0.25, which is you divide by half and divide by half again, you divide by 4. You just divide this thing by 4, and then 6 divided by 4 to save time. This 23 should be what it is, okay? Only to divide this whole number. 6 divided by 4 should be 1.5, if I'm not mistaken. So 6 divided by 4 is 1.502. 1.5 might not be too accurate, but just 1.502 times 10 raised to the power 23 should be the expected answer. Ions, though then use a calculator here. So the next question says, can phenolphthalein be replaced with methyl orange in the titration above? The answer is no, because the titration is between, give reason or reasons for your answer which will follow it. The titration is between a weak acid, and since they have told you carboxylic acid, all carboxylic acids are weak acids, all organic acids are weak acids. Titration is between a weak acid and a strong base, which is sodium hydroxide, and the suitable indicator is phenolphthalein, not methyl orange, because of the pH transition range of the two indicators. So choice of indicator is determined by the pH transition range of that indicator and the strength of the acid and base being titrated. All right, we will have another video now where I will handle this qualitative analysis, what we commonly call salt analysis. All right, I really still appreciate you for watching. You remember that you are still on with the majestic tutorials, the home. This is the home where top educators covers simplified lessons across. Then if you are looking for a private tutor in sciences and major art subjects, we have experts. I handle you in chemistry and biology related courses in the university. If not for O-level, WAEC, JAMB, JUPEB, we are ready to give you the best at the cheapest affordable prize. So go conquer the exam and come back with testimony. Much love. Stay majestic. Bye for now.